Hey, welcome to NASA Science Uncut. I'm Tom Wagner, your host, and today we're going to be talking about the Arctic, and our goal is to get kind of behind the headlines and talk about what changes are going on there, how we know what we know, and what the world holds in store for us. And to do that, I've got three great friends from NASA who are also fantastic scientists. Laura Koenig from NASA Goddard, who's an expert in polar snow and ice. Thorsten Marcus, also from NASA Goddard, who's an expert in sea ice at the North and the South Pole. And also Waleed Abdulati, who's the NASA chief scientist right here in headquarters and has spent his career studying how changes in the major ice sheets affect sea level. So thank you very much for coming, guys.
Thank you.
Thanks.
And so to start us off, we just want to talk really quickly about what the goal of NASA Science Uncut is. And our producer, Cedric Harris, actually said to me, he said, when we go and film NASA Science TV, a lot of times the most interesting conversations happen when the scientists think the cameras are off. And so what we want to do is try to recreate that here and just have a conversation about the changes that are going on in the Arctic. But before we get to that, what we really want to start over with, I think, is the question that a lot of viewers have. What's it like working at NASA? And so Waleed, why don't you take it away first?
Sure. It's great working at NASA, particularly as a scientist, because we are really at the forefront of some of society's greatest achievements in human exploration, in scientific research, in technology and engineering. So it's so stimulating in so many ways. And as an earth science, particularly one who studies cold places that are kind of hard to get to, there's a special thrill because the satellite and airborne perspective give us a way of looking at these places that we can't achieve any other way and really reveal the secrets that have been hidden from humans for thousands of years.
Yeah. How about you, Laura? What's it like? Because you kind of, you just started a few years ago at NASA, right?
I started 4 years ago, and I came right out of my PhD program, came right here to NASA, and I couldn't have wished for anything better, actually. It's such a great place to work. It's exciting. We have twice a year aircraft flying over the polar regions, new data coming in all the time. On top of that, I get to work with some of my colleagues who are just the greatest scientists in the field. And it has just been an honor and a pleasure to come here and work at NASA, look at new data all the time.
Okay, now Thorsten, you run some major missions, so tell us what it's really like to work at NASA. Okay, enough with the,
Well, I think overall, being a scientist and maybe being at NASA in particular is extremely playful. We just play around with data, we take measurements, try to make sense of all the data that we are collecting. And Waleed mentioned polar regions. I mean, I think, my career at NASA has been fantastic. NASA gave me the opportunity to, as Laura said, fly over the poles. I flew over the Arctic, I flew over the Antarctic. I went on an icebreaker and took measurements on the sea ice right next to penguins. It's I don't know, it's science, it's playful, and you do exploration, space exploration as well as, exploring, the ice in itself.
So the reason that we're all here today, too, is to talk about what's been going on in the Arctic, right? Where all of you guys have gone and worked and things. And what we really want to hear about is your personal perspective on these things. So let's just recap what's gone on in the last year. The sea ice melted back to the lowest that it's ever been. The entire surface of the Greenland ice sheet melted. What does this mean? Are we taking the Arctic to a new state? Laura, what do you think?
I think the changes that we're seeing in the Arctic right now are just a continuation of this warming that we've seen and we'll continue to see into the future.
But Waleed, when you started working at NASA, right? I mean, it was a different time. We didn't have this kind of change going on in the Arctic.
That's right. We had only recently developed the tools that let us even look at this kind of change. So, it takes time to build up observations to assess the meaning of what we're seeing. And yes, when I first started, we could watch the ice grow and shrink. We could watch it melt and refreeze. But it was through this persistent observation that we've been able to watch that turn into a trend of increased melting, into a trend of decreased sea ice cover, into a trend of lost ice mass on the ice sheets contributing to sea level rise. So yeah, I've been lucky in a sense to have been a part of the transition where we went from first figuring out how to look at these kinds of things to actually looking and observing and understanding the kinds of changes we're seeing and observing this transition.
So we should probably break it apart, right? Like, so when we talk about the change in the Arctic, first, like, let's just start with the sea ice, right? Floating ice on the cap of the polar ocean. Thorsten, what's been going on with this thing and how do we study it?
Well, the cool thing about NASA is, and the only way to study the polar regions on a frequent enough level is from satellites. So, in looking at satellites provide the only means to look at the polar regions on a daily basis, and we've learned so much from the satellites. And the Arctic, the sea ice, it's not like a frozen lake that just melts and freezes over. It's a highly dynamic system. It opens and closes. Ice is leaving the Arctic or the Antarctic system through currents along Greenland or along the peninsula.
We've had satellite measurements since the 70s, right? And I mean, why is it so important that what's going on with Arctic sea ice now? Like, what's happening that's such a big deal?
We've been monitoring the sea ice.
Like, it melts every year, right?
It melts every year. It grows back every year. And we've been monitoring, as you said, the Arctic sea ice and the Antarctic sea ice since the 70s, late 70s. And we saw early on when I was a PhD scientist, we saw there's a slight decline in the sea ice. But the climate changes all the time. It started like in the 2000s when those changes became more and more profound. They became bigger. They became more.
Well,
they happen every year.
Right?
They happen
so
every
when
year.
we talk about the decline, right? And I'll throw it open for anybody to talk about. What do we mean by decline? Like I say, every year we know that the sea ice, it grows, it melts. It actually goes all the way out from outside the Arctic, right up around Greenland, up around Alaska. The summer months it melts back, and lately it's been melting back more than ever, right? It's also thinner now than ever, right? So, but I think it's hard for people to put that in context, because they know that it's always been this natural variation thing. What is it that's going on right now that's so special?
Sure. Well, the Arctic grows, as you said, and shrinks and grows and shrinks. And over time, we've seen that it's shrinking to smaller and smaller levels. And what's significant about that is a couple things. One, just in terms of recovery from that, new ice is inherently thinner and more vulnerable than that old ice that used to survive the summer melt season. If you throw into the mix the fact that this sea ice traps energy in the ocean, it's a barrier between the ocean and the atmosphere, so it affects weather, it affects climate, it affects ocean circulation, it affects the movement of air in the atmosphere. So human civilization has never known a time when there has not been sea ice in the Arctic in the summer. And we appear to be approaching that time. As
Yeah,
Thorsten
right. I
was
mean, the
saying.
whole history of explorers looking for the Northwest Passage, right? All getting trapped because there was too much ice.
Exactly.
And now they can go
and
through.
Now they can do it. It's a summer sail. And so this sets up potentially a very new environment for human civilization that we are not familiar with. We haven't experienced. We don't exactly know what to expect. So the significance of the trend we're seeing is that it seems to be taking us to a new place where we've got no experience.
When you say no experience, like we're talking about changing weather patterns over North America, we're talking about, look, we're trying to get beyond the headlines, right? Which is, we talk about changing in the ocean, right? How's the Arctic connected? I mean, it's hard to believe that changes at the top of the planet affect us in other parts of the world.
Oh, it affects us profoundly. I mean, the very ocean the Gulf Stream, something that we all
warm water
understand.
coming up along the east coast of the U.S.
So you have very different temperatures off the coast of Virginia than you do in Massachusetts because you've got the warm water coming up along the southeast and then it veers off into the Atlantic. That kind of circulation, the Kuroshio current in Japan, these major ocean circulation patterns have their roots, have their core in what's happening in the Arctic and Antarctic. It's the presence of ice that sets these things up and allows them to happen. With that ice going away, we're not sure what the response is. All we can expect right now with confidence is that it'll be different. What different means is still subject to interpretation.
The maps. And that's a lot of what we do, right? Like I say, we take it for granted. We see these pictures of the planet from space. In the Arctic, it's dark for 6 months of the year.
It's actually trickier than you think, or than most people think.
You're all looking at this. I'll be the prop guy.
Yeah.
Well, the point is really,
I'll
most of the
stand.
time it's dark, especially when you have absolutely zero sunlight. the way it works, many people have seen these thermal infrared images of houses of people with a thermal infrared camera.
Yeah.
And just like visible light, it's not just the visible spectrum that you have the sunlight also has a portion in the ultraviolet. And in the same way, the thermal infrared radiation from the Earth has a portion in the microwave range. Very, very long wavelength. And we are tapping this radiation to monitor the polar regions. And why these microwaves are so great is they penetrate clouds. And that's phenomenal. They're a passive sensor. We can just have a microwave radiometer over the pole and measure the radiation. And we can measure the radiation through the clouds. So only with microwaves, we can actually get daily images of the entire Arctic and the entire Antarctic.
So we have really good maps.
Oh, we have
I mean, this is
phenomenal
one thing.
maps.
We know this
We have
really well, that we're
phenomenal
losing that ice. Go ahead,
Well,
Laura.
in these maps, as Torsten was talking about, they penetrate into the snow. So over the ice sheets, and even over seasonal snow in the U.S., we can gain information from these satellites about something as small as a snow grain change. And that's very impressive. And I would say to the audience, you can take a very cold ice cube and put it in your microwave that you have at home and turn it on, and you'll see that the microwaves will penetrate right through that ice. It won't melt. So as long as it's a very cold ice cube, you can have it in there for 20 seconds, it won't melt. And that's exactly what we're using with these satellite sensors to look at how the ice is changing from everything from the entire extent of the polar sea ice to small changes in grain size over the ice sheets.
But if you do try the experiment, don't go for like 5 minutes.
No.
Forget to take it out.
Once there's water, it'll absorb.
Hey,
Yeah.
so let's change gears. So again, the other component of the Arctic change, right? We talked about the sea ice, the land ice, and we've got glaciers in Alaska and small ice caps and things in Alaska and northern Canada, and then we've got the major ice sheets of Greenland. And we had a big event this summer, which we had melting all of the surface of Greenland, right? Laura, tell us what that event was like and why it's important and how you learned about it.
Well, first, and joke, I did learn about it from Facebook posts from scientists who were there on the ground saying, hey, it's really warm here, and showing the melt runoff. So at the very top of the ice sheet, it'll probably just melt. It'll penetrate down. Just if you think about a warm day and seasonal snow at your local ski resort, it'll just penetrate down a little bit, and it'll
So
refreeze.
Greenland, thick, miles thick of ice sitting on a continent.
Miles
right?
thick.
And you're talking about just the surface
Just
now.
the very surface, at the highest elevations of the ice sheets. At the lower elevations, there's actually much more melt, and it'll form rivers, it'll form lakes, and that'll run off. What we saw this last summer as well was the rivers that take that water off the ice sheets were just swelling, and it knocked out some bridges. And so those were all posted on Facebook even before I had seen the actual satellite, the satellite data. So we knew that the satellites were real. And if I can talk some personal experiences, I was very surprised. It melted at one of the highest elevations on the ice sheet, a place called Summit Station, Greenland. And I've actually wintered there. I've been there when it was negative 86 degrees Celsius. It was very cold. And I didn't really expect it to melt. I know it has melted there. I've drilled ice cores down, and where you see the last melt event is about a 40-story building deep down into the ice sheet. And you'll see the fern, what we call it, year-old snow.
Hold on, pause there for a minute. We talk about ice cores all the time, right? Let's just explain really briefly what an ice core is and what it represents.
I think of it like tree rings.
Yeah.
So people are pretty familiar with tree rings. Each year the tree grows and creates a new ring. Well, similarly on the ice sheet, in the interior of the ice sheet, what we call the accumulation zone, with each year you get snow that falls and it's very cold and that snow doesn't melt, so it piles up, it makes a layer. A layer every year. When we're closer to the surface, one thing that the ice sheets do is they'll compress down. So those layers will compress down over the weight of the ice as they build up. And tree rings will just continue to grow out. They don't compress. But it'll compress down, and even in the surface, we can count back annual layers and look at temperature changes, changes in the atmospheric conditions from air that's been trapped in those ice cores. And we can also see, just from the stratigraphy, where these melt events
So it's
occurred.
like a tape recorder of what's gone on over the ice. And we're saying we haven't seen a melt event like this except for a very, very long time ago. But why is this melt like, okay, so what? So we have some melt form on the surface of the Greenland ice sheet. Why is that a big deal? I mean, maybe we'll just get more snow this year. What do you think?
Well, it's indicative of a broader change. You can imagine very high altitude ski resorts in the winter, and you get a warm wave and the slopes all experience some melting. Well, intrinsically, that little bit of melt, I mean, it may ruin some of your skiing, but intrinsically, that little bit of melt may not hold meaning in and of itself, but in the context of what made that happen, it holds tremendous meaning. So to see the Greenland ice sheet experience a little bit of surface melt in this way, though not unprecedented, we see this in the historical record, as Laura had pointed out. When you take that in the context of all the other things that are happening on Earth, all the other changes that we're seeing, it's indicative of what appears to be a shift. One thing that's been true of both Greenland and the Arctic sea ice cover is when we have observed changes, when we've developed the capabilities, we've consistently been surprised. The rate of Arctic ice decline has just been faster than we thought it would be, or perhaps even could be. In the case of Greenland, you know, there was a time when I was looking at data. This is my eureka moment, where I was looking at data on one glacier, the Jakobshavn ice stream, fastest in the world, used to move about 7 kilometers a year, and it doubled its speed. And I didn't believe.
Yeah, it's hard to believe ice can move like a
well,
river
and I
at
didn't
all.
believe my data. I didn't believe my results, and I kind of sat on it for a while. I'm like, what am I doing wrong here?
How did you make that measurement?
That was I used visible imagery, so basically
So like a
pictures,
picture.
right? And I watched the movement of the crevasses from year to year. And so it's pretty foolproof, you know.
Yeah.
You find the crevasse pattern, and then you look at it a year later, and you see how
Yeah.
much it moved, and you calculate the distance. There are other ways to get more comprehensive velocity measurements, but you know, when I first saw how much it moved, I thought I must be looking at the wrong crevasses. You know, it just this can't be.
Yeah.
And then it turned out others were seeing it. And when we combined it with how much the ice was thinning, so it's kind of like gum. You stretch it out, and it will slump, it will thin. We put together a story of that this was real. This was really happening.
And it wasn't a single glacier.
In this case, it was,
well,
but it started happening everywhere, and this was a total surprise to us. We didn't think it could happen. We thought it was kind of going as fast as it could go.
So let's put it all together, right? I mean, what we didn't have time to talk about was we know that we have these glaciers in Alaska that are melting dramatically. There's incredible footage of that stuff on the web. So we're losing the sea ice cover. We're losing the ice in Greenland, right? How is it tied up? Like, what's, like, you know, is it just that the planet's warming up? I mean, what do you guys put it all together?
Well, the Arctic is warming about twice as fast as the rest of the planet. And there are reasons for that. It wants to be cold. It reflects the incoming sea ice. It traps heat in the ocean. So when we start to lose the ice, or the ice starts to melt, it absorbs more sunlight.
That's
so the
consistent with
ocean
models.
heat gets out. Exactly.
Models of temperature of the planet.
Yeah.
Yes. So there is an amplification factor
Yeah.
in the Arctic. So what you're seeing is the manifestation of that, coupled with some other complexities that Torsten or Laura might be better able to address than I. But
So let me throw this other thing, though. It's, you know, on occasion, you'll hear people say things like, well, in Antarctica, at least the sea ice looks like it's growing. You know, what does that mean? And how do you put that in this context of, like, you know, it seems like we're losing ice for most of the planet, but we're gaining ice, it seems like, at least in the Antarctic sea ice.
Well, it's a complicated question in a way, because there are two different answers. A, Antarctica has a completely different climate system than the Arctic. And global warming doesn't mean it's, you know, equally warming up everywhere. You know, there are some places, as Waleed said, the Arctic is, you know, warming up twice as fast as the rest of the planet. Antarctica is not warming as much as the Arctic.
Yeah.
And of course, the whole climate system is different in the Arctic and compared to the Antarctic. In the Arctic, we have polar ocean, which is surrounded by land. In the Antarctic, it's the other way around. We have the pole itself is Antarctica, a continent surrounded by water that has sea ice occasionally. So you cannot compare, that easily Arctica and Antarctica.
So you can imagine you can still have a warming world, but have sea ice grow a bit in the Antarctic.
Look, here's a good analogy. You can look at the stock market. You can look at the S&P 500, and it may be trending up, it may be trending down. If it's trending up, chances are a lot of the stocks are trending upward, but there will be stocks that are going down. And the converse is also true. So what we look at in Earth system science is the Earth system. And the system does things as a whole, but there's a lot of spatial variability to it, some of which is counter to the behavior of the system as a whole. But that's in large part due to the movement of energy from one place to another.
All right, so where are we headed? I think that's probably the biggest thing. So we take all this knowledge, right? The next 100 years, what's the planet going to look like, Laura?
The next 100 years. I mean, I think there'll be less ice in the Arctic, and I think we're still discovering a lot. So here at NASA, we have all these tools, and Waleed talked about his eureka moment, and I think all of us have these eureka moments of we're looking at new data all the time and discovering new things. I've been looking at a lot of data right now showing that we have a lot more water, liquid water, in the Greenland ice sheet than we ever thought about before. And we still need to understand some of that before we can say exactly what's going to happen. But we know a few things for sure. We know that there'll be less ice in Greenland. There's going to be more fresh water released into the Arctic. There'll be less sea ice.
Well, I think, there are model predictions of what the future will look like. I do think the things we can say with high probability, oceans will be higher. In the next 100 years, perhaps a few feet higher. Actually, probably a few feet higher in the next 100 years. The Arctic sea ice cover, essentially gone in the summertime.
Probably.
Yeah, and the implications on the climate, we don't know for sure. We can reasonably expect more intense weather events, whether they be precipitation events or drought events. So
big change across the planet.
Potentially, and the models say likely.
Yeah.
Where we can't go is certainly.
Seriously, 100 years out, all the time you've spent in the Arctic, what do you think it's going to look like? Going to be dramatically different?
Oh, absolutely. I have no doubt.
The Arctic will certainly be dramatically different.
The Arctic will be ice-free.
In the summers.
In the summers. And people ask, when? Tell me when. And I said, I don't know. And this is not a good answer, but it's a scientific answer because, we will never be able to perfectly predict the future.
Is whether or not it's ice-free in the summer really important, or is it, look, there's already massive amounts of change going on, so it's going to look pretty different no matter what. The ecosystems are changing. We know that there's different organisms moving, and we know the planktons are changing.
Look, it's not about when the last little berg or floe is gone. It's, as Torsten said, you can't say how many cigarettes before you get cancer. You can't quite say what the area will be before we transition to a new state. Yeah. What you can say is there's a strong trend that continues to surprise us. We're headed in a certain direction with potentially dramatic implications. And I think we got to get away from that, what is the date on which the last bit of ice will disappear, and focus on the trend.
All right. Hey guys, thank you very much for coming in. We want to thank viewers, thank you very much for tuning in to this episode of NASA Science Uncut, and we look forward to seeing you at the next one.